Okay. Now, so welcome again here in our lecture hall B1 in Hohenheim for the final plenary session. We have an assorted audience here. And after some very interesting sessions yesterday and the day before, with some challenges, particularly in terms of technical issues, and very interesting solutions for actually presenting. I was amazed how many different ways of presenting a poster in a video can be done. So it was really interesting. So for me, it was an absolutely new experience and I enjoyed it a lot. It was weird in a way, but one thing, it was also very quiet, you know, other than normally the guided poster sessions in Tropentags, which are very loud and extremely stressful for me as a guide. It was very easy. So I also would like to thank all the people for their patience. And there was a perfect technical help in Witzenhausen. So I felt very comfortable with the sessions, and I hope that everybody else had a similar experience. Today, we are closing the Tropentag in about 3 hours. And before we do this, we would like to come back again to our main topic, which is food security, food and nutrition security, and its resilience to global crisis. And we have heard some talks. I don't know if you were able to listen to the GIZ session, for example, or also the BMBF session, sorry, the BML session, where this topic came up again and again and again in very different aspects. And we introduced the topic in the beginning with two people who were focusing on children and on nutritional issues. And now we want to continue and having a wider look in global crises, not necessarily on a direct impact on humans, but maybe more related to ecology. And finally, coming back to economy. And I'm happy to announce that all our keynote speakers are actually virtually present, and one of them is actually physically present. He came here extra for this keynote into our lecture hall, so that we make a point that we actually want to be together and not separated by internet things and screens and stuff like that. But we actually would like to be here in a physical contact. And of course, we are keeping our distances, yeah, but we are here. So all of them are here, and we will have the first keynote by Petra Schmitter, who is an Hohenheim alumni. And she has a master's in bioengineering and environmental technology from the KU Leuven. And that was not enough for her. She did another one, also in Leuven, on water resources engineering in 2005. Then she came to us and did a PhD in agricultural science from the University of Hohenheim in 2011. And as often, we have to send our young people out, and she went, joined Africa Rice for some time, and is now with IMI, senior researcher at the International Water Management Institute, and she's leading the research group on sustainable and resilient food production systems. Her research focuses on developing adapted water solutions for smallholder farmers to improve their agricultural resilience. And over the past 14 years, she has mainly worked in interdisciplinary research for development projects in Southeast Asia, West and East Africa, in the field of farmer-led irrigation, water productivity, irrigation scheme modernization, land degradation, and hydrological modeling in development programs. And I'm looking forward to the talk. As always, we asked our keynote speakers to address the main topic of the Tropentag, and we will see what Petra made out of it. Petra, the floor is yours, and I'm looking forward to your presentation.
Thank you very much, Volkert, and thank you very much for having me today. I'm currently struggling a little bit to share my screen because I don't seem to have sharing rights. I'm not sure if somebody could actually help me with that. I just put in a request. Okay, just a second. So I think I managed to overcome a
Yes, very
technical
nice.
difficulty here. Okay, great. So thinking about the topic of this year's Tropentag, I wanted to highlight the crucial role of water in enhancing food and nutrition security. I'm sure that some of these numbers have been occurring a number of times in today's conference, the need to produce more efficiently or food going forward, but also dealing with the number of people that are being displaced by droughts and floods and are dealing with water scarcity in several arid and semi-arid areas. And if that wasn't simple enough yet, of course, as we have seen this year, in the face of a global pandemic, we have to deal also with disruptions of local markets, national, but also international trade. And all of that actually asks the question, how can we produce and build more resilience, especially locally in a lot of these rural areas in developing countries? And then I think you mentioned earlier, the topic has been raised around childhood stunting, and that even further exacerbates the need to really think through how we build food and nutrition security at a local level. So today I'm going to focus on a smallholder perspective because they do produce a significant portion of our food plate, of the global food calories, and a lot of that happens on farms less than 2 hectares. And we see across the globe, if you look at the Global Commission for Adaptation report, that a lot of these farms do experience or are exposed to crop yield vulnerabilities in various degrees across the world. And water plays an important role in that, not only from a adaptation perspective, but also from a mitigation perspective. So let's look at, for example, Myanmar. We looked at the dietary patterns compared to the Lancet recommended diet, both at national level as well as regional level. And we looked at how that actually translates to the local production system. What we see here is that there is a surplus of calorie intake in terms of the starchy staples, which is predominantly rice, not uncommon in Southeast Asia. And that translates very much into also the local or the national policies and production patterns in the country, where around 50% of the food produced actually covers the rice and to some extent also wheat. When we look at the amount of water that actually goes into producing those different food groups, we do see that actually more than 50% goes towards rice. And this is very much in a, oops, sorry for that. It's very much rain-fed, only 5% is being irrigated. And if we look at the vegetables in the lower right corner, for example, we do see that despite the low production of vegetables in the country, 25% is actually under irrigation. Again, not very uncommon given the nature of the crop and the need for the vulnerability. Now, when we put that in perspective, of course, we see that the majority of the staples being produced on the rain-fed systems are quite vulnerable. And that is highlighted by another example, some of the work we did in Jordan, where we look at the vulnerability of cereal production since the 70s, actually. And we see that that has actually triggered quite a number of policies and investments in water irrigation infrastructure to actually overcome some of those shocks, not only on the drought side, but also there has been a number of occasions, flood, for example. And so it raises the question, to what extent do you actually invest in irrigation infrastructure or in other water management solutions to actually support not only your staples, such as cereals, such as rice, but also how do you or when do you decide to target some of that water towards a more nutrition rich diversity of your food palette in country via the export and the trade policies. So I wanted to circle in a little bit more today around, how can irrigation really support nutrition and food security from a smallholder perspective, and deep dive a little bit more into what we call farm-led irrigation. This is an example in Ghana where we actually looked at how much area is really under irrigation, how is it actually managed. And we see that the majority of the land being irrigated is really in the hand of farmers. It's very little actually is through public investments in schemes or in small reservoirs, and a lot more is actually under irrigation, where farmers have the agency and have made their own investments. And overall, that area is supporting significant portions of the vegetables being produced in different sides of the country. But then we also see that a lot of the urban consumers do actually deal with contaminated vegetables as well, which then raises a question not only about how much water do we have and can we put towards nutritious food production, but also to what extent is water quality an important issue to take into consideration when deciding on where and how to irrigate. So let's look a little bit at where we see potential for expansion. So we use a lot of the remote sensing and open data sources to actually identify in which locations water is sufficiently available to support ongoing food production systems or support farmers in transitioning to other type of crop production systems. And we see in this particular case, and for off-grid solar using shallow groundwater, there's quite a lot of potential in the upper east part of the country. But if we actually look at the vulnerabilities towards climate change, we see that the suitability of that irrigable land is shifting, that from the 1 million hectare that could have a potential to currently support smallholder resilience, either in a rainy season or off-season production, that actually decreases by at least 10%, depending on, again, where you are located in the country. And that, of course, raises the question, to what extent do you help invest and transform at the moment, and how do you actually build flexible and robust solutions going forward? Because 30 years from now is actually not that long. So another example is in the highlands, for example. I mean, often farmland irrigation happens near rivers, near dams, but how could you build resilience in areas where you have highland areas? And this is an example of Ethiopia, where we actually looked at shallow groundwater tables that decline very rapidly post-rainy season, and whether there would still be enough water available to support off-season or supplementary irrigation. And in this particular case, we see that water actually is only available maximum around 100, 120 days, just enough to get one crop in, but it's highly variable of where that household is actually located in its watershed. And therefore, not everybody in one watershed actually would have the same opportunity to partake in irrigation, and actually would require different investments or different solutions. We see that when we look at the crop production side as well. So different households in the watershed were producing the same type of vegetables, but they did experience, of course, a different number of water stress days that weren't, where water wasn't sufficiently available from the shallow groundwater. And that, of course, resulted in a different productivity gain, income generation, etc. So it's very important to understand actually to what extent water is available at the different scales to really identify the right solutions and the potential to support food and nutrition production at a household level, but also, of course, at the communal level and beyond. And that actually brings me to the second point of today's talk. On one hand, it's important to understand to what extent we can support, but to what extent also do we have to better manage the water? We know that over 70% of the global water withdrawals and more than 80% in agrarian countries actually goes to water and agriculture, that there is a lot of ongoing issues around allocation, water management, and conflicts around where water goes, not only in the agricultural sector, but also across the different sectors. So if we look at the different scales, and we go from a crop all the way to a region or a national state, we really have to figure out what are the objectives of better water management to support food and nutrition security. And that can look very different from a smallholder farmer to, for example, an irrigation scheme manager or a policy agent in a country. And we have to actually take into account the environment in which that smallholder farmer plays itself in as well. So therefore, you would have different drivers of change to actually support better water use in agriculture. And I will give a few examples today of how we approach that, because of the fact that you have different actors, not only at the farm level, but also along value chains, influencing markets, influencing the enabling environment, you can actually really identify the different actors and the different incentives. But also we have to address the different barriers that actually go hand in hand in really tackling some of those water use opportunities, because often we start from a technology perspective trying to increase efficiency, but there are often a lot of other influencing factors, and I will give a few examples in that today. A lot of the work we do at the moment is looking at ways to really understand abstraction behavior and using new methodologies in doing so. Often we revert back in the past to household surveys, some on-ground measurements, but often that gives a very snapshotty picture, and you don't really understand, all the different drivers that happen along a season or over multiple years. So we are looking at ways to actually harness the data from pumps, for example, to look at what are the patterns within a day, what are the patterns within a cropping season, and how does those decision makings on when to use water for specific crops actually influence the productivity and the resilience of the farming system. And this is an example. It's still ongoing work, and I hope at some point we can come back and actually present some of the final results. But we do see that in Kenya and Uganda, depending on where those pumps are actually being operated, there is a big spatial pattern that is influenced by not only the availability of the water and the markets around in which the farm situates itself. So it's really interesting to start looking at some of those correlations and influencing factors when we talk about our production systems. And this actually links to some of the behavior that we have seen in Jordan, where the push actually for dealing with declining groundwater tables has shifted a lot of farmers to drip irrigation. But still, nevertheless, we see that these groundwater tables continue to actually decline. So looking at those households, we see that actually the behavior, despite the push for more efficient technologies, still is very much related to the perception on water scarcity. More than 60% of the households that we interviewed actually looked or showed that farmers did experience severe water scarcity at some point, which resulted in significant yield losses. And that actually led to still a number of farmers actually over-irrigating. When they were asked to then to upgrade their system or identify other solutions, actually a lot of them opted for climate advisory services rather than novel, more efficient drip kits. So that again shows that the behavior of water use in agriculture is not only or cannot only be tackled by looking at the technology side of the chain, but really has to be situated within the wider scheme of things. And this is also something that we see when we look at ways to create that adaptive learning, to provide that information to farmers, depending on the crops that they grow. And this is an example where we look at chameleon sensors, because we still see that a lot of the climate information doesn't reach a farmer or actually stumbles upon social cultural challenges in interpretation, translation, etc., to be really useful. So we looked at other ways to identify or provide similar information for better decision making, but really let the decision up to the farmer. So it creates a learning process by actually identifying how wet his or her soil is. It's a simple color coding system. So a LED light shows either my soil is wet, my soil is dry at this particular depth, and hence he or she adjusts when or how much to irrigate. And we really do see a significant shift in the amount of water being produced. And at the same time, because you put it actually in a context of a community, you start having these social networks and these discussion points about, okay, I have irrigated so much, this is what I do. And it helps not only the on-farm water management, but also the water user groups actually in which those technologies are situated. Another opportunity here to actually look at water use in agriculture is actually providing the incentives within the food chains. This is an example of the coffee sector in Vietnam, where we used past information to actually identify an irrigation benchmark for coffee in the Central Highlands, and that was around 400 liters per tree per round. That information was actually then used by the private sector to provide their extension services to the smallholder farmers in the Central Highlands. And of course, it's a very intensive process, and it requires quite a lot of human and operational resources. But it was worthwhile when we looked at the return on investment. Not only did it double the yield of the actual coffee producer himself, but also actually created quite an economic incentive for the private sector companies involved. And that actually brings me to another point. I mean, often the farmer doesn't really have an incentive to save water unless it is related to an economic gain in one way or another, or it has other social values. And it's very important as we talk about water use in supporting our food and nutrition resilience to find out what those incentives are and what those triggers are going forward. But of course, that doesn't happen in silos. So it's very important that these policies in the enabling environment really needs to support those incentives, and not only from a water perspective, because often water and energy goes hand in hand. So it's really about linking the water and energy policies to our food production systems and country. So this is my last slide to kind of summarize today on some of those key messages that I would like to get across. It's really important to understand and focus on some of the adoption opportunities for smallholder farmers for nutrition and food security, because it is an important part of our food plate or chain. But it's very, very variable in space and time. So it's really about understanding and getting better data to help guide those investment decisions and start untangling the different opportunities. But then, of course, hand in hand, make sure that those smallholder farmers are actually incorporated in governance, planning, and policies. Often they are not part of the water debate or the water discussions. And that's going to be a problem going forward, especially given the role of water and food and nutrition security. So we really do have to find out or support the water rights because they will be losing out given the complexity of what we're dealing with at the moment. And then there is a lot of opportunity, of course. It's not only about looking at the technologies that can offer some of these water solutions for food and nutrition security, but also to understand the drivers and the water risks that smallholders face and create adaptive learning to support them. And then last but not least, I mean, we look a lot on farm and farm production, but often the solution is in the agricultural value chain. So it's really about linking the scales, linking the actors, and find private and public incentives to help improvements going forward, because it's often, as I mentioned earlier, an issue around economic incentives, labor, or regulations to really achieve what we set out to do. So with this, I'm finishing my keynote for today. I would like to thank you all, and I'm happy to address any questions. And if you're interested in working on water-related topics, do please feel free to reach out anytime.
Thank you, Petra, very much for this interesting keynote. And I hope you heard some of the clapping from the room here.
I did.
It's a bit a scattered audience, but they try their best, you know. So thank you very much again for this really interesting overview of what you are up to. And I haven't seen any questions in the online questions and answers, but I'm pretty sure that there are some questions here in the audience. I see Thomas already nodding. So hold on, I have to pass the mic.
Thank you, Petra, for your nice talk. It was really interesting to see what you're doing now after your long time up here in Hohenheim. I wonder a little bit, we usually, and you addressed that also in your talk, in drier areas, we also have a lowering of the water level in the soil. Would you think, for example, some measures at stakeholder levels, for example, to use some kind of badlands, wasteland to direct water, for example, in a way that it can be used later on for irrigation purposes. Would that be also an opportunity to look at in the future, and also to foster or even to enable people to do something like that at local in local in the local context?
Yeah, sure. Thanks, Thomas. Yeah, no, absolutely. I mean, I didn't address, of course, the role of nature-based solutions and other opportunities, especially in semi-arid and arid areas. We do have worked on a combination of looking at how you can divert the water. And that, of course, brings a whole new set of challenges. You know, how do you actually compensate or redirect or ask one community or a few farms to store water in one particular part of the catchment and use it in another site? There are some interesting examples where we look at underground storage, for example, managed aquifer recharge opportunities. Those are actually solutions that allows very rapid infiltration. Actually, that's great for areas where there is some flood risk also in the rainy season. So you temporarily redirect it, store it below ground, and then you could use it in the dry season. And that seemed to work well in areas like, for example, if you looked at the flash floods in Sudan some weeks ago. So there are definitely a lot of opportunities, but I think some of the key here is still to come back to soil fertility and carbon, and the way that we actually can continue to increase our water holding capacity. I mean, storing water is one pathway, of course, and an important one, but we also have to continue to work on storing more water in the soil itself during the cropping season going forward.
Thank you for this answer. And now these people are waking up in the questions and answers online. So, and we have more questions here even, but we don't have that much time. So I would like to give at least one question here from the audience in questions and answers. And there is a question of Matthias Becker. He says, we observe throughout Asia and parts of Africa a shift from irrigated dry season rice to less water consuming vegetables. Could that be a solution for increasing water use efficiency and nutrition security? Do you have comments on that?
Yeah, short answer, absolutely. I think, but okay, so actually there's a more nuanced answer to that story, I think. On one hand, yes, I mean, we have seen that in the central dry zone in Myanmar as well, where we shifted from rice to crops like chili, bitter gourd, etc. And that doesn't only improve the amount of water being used within that particular season, but it also actually, in this case, it was pump-based irrigation, helped to reduce the energy pressures that we were having. But in areas where staples are sometimes not as water demanding. So rice is an example where the shift is easy or easier because there's quite a lot of water that goes into it, but Ole is going to talk later about alternate wetting, drying, and ways to overcome those. But for some staples, actually, the shift to vegetables will create an increase in water demand. So again, I think it's very situation dependent and looking at really where we can and how we best can make that shift. It won't hold always for all staples.
Thank you. And there's another question here from the audience by Professor Kadish.
Yeah, hi Petra.
Hi.
Thank you very much for your interesting talk. And you showed some very nice pictures about solar panels and so new technologies. And there is always an interesting conflict between energy and water. No? We have a lot of dam used for water energy production. On the other hand, energy and water can also be successfully combined. As you show, how big do you see this kind of potential also for small-scale farmer? Because obviously it is probably a major investment.
Yeah, good question. So the slide I showed around all these solar pumps providing their data were actually smallholder pumps. Costs have gone down quite a lot, but there's of course still a lot of challenge around the financing aspects, and there are quite some new interesting finance modalities that are being developed by the private sector. But that said, I think a part of that trade-off, or that looking at the different challenges here, is also how do you safeguard, of course, the water resources, because you kind of have almost zero marginal costs associated with solar via other types of water lifting, energy consuming technologies. So there's some of the considerations also to go forward. There has been a lot of work done on subsidies for solar in India, but that doesn't always translate very well in Africa, or we see that very differently in Africa actually going forward. So aside from declining costs in solar panels, etc., I think there's still a lot of work to be done in understanding the different market segments, let's say, for the smallholder solar communities, but that has to again be linked very much to the agricultural value chains, because we see also that the payback for any type of investments, even if feasible, will highly depend on what crop you grow, or the combination of crops you grow within a year, and that's really crucial.
Okay, thank you very much. And we still have time for one more question from the audience out in the internet. There is a question here by Andrea Fadani from the Fiat Panis Foundation. And he is worried about how this research that you are doing, particularly IFMI, I guess, how this research makes farmers stronger in the process. So how does research actually help making farmers stronger? Is there a direct link, or how do you see your role in this?
Very good question. It might not have become very clear from the keynote today, but it's very, very much farmer-centered. So all of the research, actually from testing a solution to understanding what happens in the catchment scale, works hand in hand with the farmers, the communities. But beyond that, we bring a lot of the different actors together through various platforms to help trigger a systemic change, because often working with farmers doesn't mean that the next neighbor next door who hasn't been partaking in that particular research experiment or implementation benefits equally. So it's a lot about figuring out how you bring your actors together, and that's pretty much the approach we take, the adaptive research approach we take, to ensure that from the onset you have everybody actually in that chain on the table, you carry out your research, and you actually create that systemic change going forward. And there are some quite nice examples in Africa at the moment, what we call living labs, pretty much.
Perfect. Thank you very much. There are more questions, but we don't have time for those. But if you don't mind, maybe you can go into the questions and answer section after this or during this session, and maybe answer some of these questions directly. That would be very nice. So Petra,
Sure,
thank you very much for being with us and giving us this talk and this discussion. That was really very nice. A big hand for Petra here.
Thank you. Thank you all.
I once more would like to point out that we have a journalist writing very busily in the blog, Tropentag blog, very interesting pieces. Also some very nice background information on how the infrastructure of that entire Tropentag works. So it's really worth looking at it. And I just urge you to look at, with one eye maybe here and there, into the blog of Tropentag and follow us on Twitter as well. Now we are coming to the next keynote, and we are moving away from water. And we are moving into rice, which actually grows in water. And there is a lot of things to be said about rice and crises. And the one who's going to talk to us is Björn Ole Sander. And I think he doesn't like the Björn so very much, so we call him Ole, as we always do. Ole is holding a PhD in inorganic chemistry from the Christian Albrechts University in Kiel. And now he works as a senior climate change specialist at the International Rice Research Institute and is country representative for Vietnam. So you can see, even with chemistry, you can make quite a career. Ole analyzes the greenhouse gas balance of different rice-based cropping systems in South and Southeast Asia. And he evaluates different mitigation options through water, fertilizer, and crop residue management in these systems. Ole also identifies or tries to identify suitable conditions to support dissemination of mitigation technologies, mitigation in the term of climate change mitigation, such as the water-saving irrigation method, alternate wetting and drying, and we are having a collaboration in this at the moment with one of our PhD students. Ole works with different stakeholders in Vietnam, Bangladesh, and the Philippines, and to foster implementation of this and other climate-smart farming practices. So he's pretty much into the climate change issue, and I'm sure that he has some insights to share with us on our topic today. And Ole, I'm happy to have you here, and the floor is yours.
even as a chemist. Yeah, thank you very much for the introduction, and good afternoon, everyone from Vietnam. I will share my screen now. Yeah, as Volkert mentioned, I will look at a different crisis, the climate crisis, which has gone a little bit out of the focus this year because of the COVID crisis. But I think it deserves attention. And I will talk about various climate change facts and give some examples for rice. I will jump a little bit to different topics, so stay with me. I will, however, start with COVID, but on a happy note.
We don't see your screen yet.
You don't see my screen yet?
No, we see you, but not the screen.
Oh, let me share this again.
Yeah, now it's not in presentation mode yet.
Yeah.
Perfect. Yes, now everything's fine. Thank you very much.
Okay, so as I said, I will start on a happy note, and that means we see a drop in greenhouse gas emissions this year. In the first quarter, we saw greenhouse gas emissions dropping by 17%, and it's estimated that for the total year we'll see a decline of 8%. You see here. The graph on the left-hand side shows the daily fossil CO2 emissions. You see a steady incline, and then 2020, a steep decline. And you can also look at this on a monthly basis, and you see there was a sharp decline in February, and then even more in March. If you look into different subsectors, you see very strong reductions, of course, in the aviation sector and in surface transportation. A little less in residential areas, but overall an 8% decline this year. Here you see the atmospheric CO2 concentration. And what you see is that there's actually not much difference in 2020. You see the same patterns as the years before, a steady incline yeah, in CO2 concentrations, a new record high this year again, with 418 ppm. And the simple reason is that we have such high greenhouse gas emissions that even if we reduce 8%, we still fill up the atmosphere with CO2, because only roughly 50% of what we emit is being absorbed by the planet. And estimations have been done that without the coronavirus this year, the new peak would have been only 0.4% higher. So Corona has done not much to the atmospheric CO2 concentration. There is another estimate by UNEP, and they estimated if we want to reach the 1.5 degree target as outlined in the Corona has fulfilled our annual goals, but we 1.5. Now, this is of course not how we want to reach our goals, but I will show you that there are other Hello?
Yeah, we shortly lost you there, and but it looks like you're back again. So
I can hear you there. Okay. Do you still see my screen now?
No,
do you hear me?
You were kicked out.
But do you hear me?
Yes. Yeah.
Okay. Well,
yeah,
I will try that again.
We were at the end of that slide, I think, what we still got.
Okay. I will try again. I'm very sorry for that. So as I said, the 7.6 reduction this, the 8% reduction this year basically fulfilled our 2020 goals in terms of mitigation, but we would need further reductions every year by the same amount. So why do I talk so much about emissions? Now, rice is quite a high emitter of greenhouse gases. You see here in the table the carbon footprint of some food products, and you see rice emits about 2 to 3 kilograms of CO2 equivalents per kilogram of rice. In that case, it's of course much lower than beef. We know beef is a very high emitter, but it's much higher than wheat, for example, and roughly in the same area, in the same magnitude of poultry. In the pie chart here, you see all global anthropogenic greenhouse gas emissions, and in green you see agriculture and forestry, and rice sticking out with about 1.5% of global emissions. Now that might seem not so much, but we have to think that also all global aviation accumulates to only about 2% of all emissions. And if we look into rice producing countries, the picture is very different. So I show here some countries in Southeast Asia all produce rice, and you see in green the emissions from rice production in the country, and in orange the emissions from road transport in the country. And you see in some countries the road transport is a bit higher, and in other countries the rice is a bit higher. But overall, rice production and the transport sector are in the same order of magnitude for rice producing countries. So it's a big factor in some countries. Now, rice is not only a bad emitter. Rice is very important. It feeds half the world's population. It's grown by 25% of the world's farmers. It's the home of many poor people live in rice growing areas, which is why the crop is very important for global development. It uses 15% of world's fertilizer, and very important also, it uses 35% of world's freshwater irrigation. It is very important for food security. Rice is the #1 global source of calories, slightly higher than wheat, according to the FAO. But also, and this is what many people may not know, it's also a very important source of protein. It's the #4 source of global protein. Not because rice is so protein rich. Rice grains have about 7% of protein, a little lower than wheat, I think. But the sheer quantities that rice is being consumed in makes it so important for protein consumptions for human. And you can disaggregate that by region. Apologize, please, this ugly slide. But it shows that in Southeast Asia, for example, it's the #1 source of protein. In West Africa, it's the #1 source of protein. And globally, it's the #4 source of protein. Now, a group of Chinese and Japanese scientists have analyzed rice that's grown under higher CO2 concentrations. Here, this is results from a phase experiment, from a free atmospheric CO2 enrichment experiment, where different rice varieties have been grown under high CO2 levels. And you see, with higher CO2 levels, the protein content has decreased. The same analysis has been done for micronutrients such as iron and zinc, and you see most rice varieties have a lower iron and zinc concentration with higher CO2 levels. Same story for vitamins. Vitamin B1, 2, 5, and 9, all of them show up in lower concentrations under higher CO2 levels. So climate change will have a big impact on nutrition security. There's another group by Mühe et al. Who have done some growth chamber experiments with 4 different treatments. They have kept today's climate, increased the temperature, increased CO2 levels, and increased both, which they called future climate. And they have analyzed grain arsenic levels, and they have found that compared from today's climate to future climate, grain arsenic levels increase. And they've done that in soils with a low arsenic concentration. They've done it in soils with a high arsenic concentration. And in both soils, the trends are similar. From today's climate to future climate, grain arsenic levels increase. Now, I want to get a little bit back from the rice grain to rice production. You may have come across these projections. They made quite some noise in the news end of last year. And they are projections done by Kalb and Strauss, who have re-evaluated the elevation of the world's coastal areas. And this was quite puzzling and mind-boggling to me, that actually there's a huge uncertainty in the elevation of our coastal areas. And we are not so sure how highly elevated coastal areas actually are. So new elevation data shows that deltas, for example, here you see the Mekong Delta, seems to be much lower elevated as previously assumed. And what Kalb and Strauss have done is projections for 2050, area in blue here that is below the sea level, or in more concrete, it's area that is lower elevated than the high tide point of the sea. And on the left-hand side, you see the projections according to the old elevation data. On the right-hand side, you see projections for the new elevation data. And you see much larger areas of the Mekong Delta will be below the sea level. Now, this is a rather grim picture, and also in the discussion, Kalb and Strauss acknowledged that this is rather a worst case scenario. But they've done that for many areas in the world. For example, here for the Chao Phraya River Delta in Thailand, for the Nile Delta in Cairo, and you see similar findings across the world. Also, Philipp Minderhout and his colleagues have looked at the Mekong Delta, and you see here satellite-derived data from before, and you see some areas in this turquoise tone indicates that the elevation is 0 to slowly below sea level, but you see a lot of brown area, which indicates it's several meters above sea level, so that an average elevation was estimated to 2.6 meters. Now, with the new model and additional ground measured data, they found that large areas are actually already around 0 elevation levels, so that they estimated new mean elevations of only 0.8 meters. And that, of course, makes the delta much more vulnerable to sea level rise. And we can assume that similar findings will be true for other deltas of the world. Now, they've also, Philipp Minderhout they have developed a model for modeling the subsidence rate of deltas. And again, they've done a study in the Mekong Delta. You see here, this large yellow and orange area indicates that from 1991 to now, so about 25 years, the elevation is lower by about 25 centimeters. So a subsidence rate of about 1 centimeter per year on average. They've also tried to model current subsidence rates in 2015, and they found that there are areas here in the lower part of the delta that currently have subsidence rate of 2 centimeters per year and more. One major factor that they have identified, and also other studies have identified, is groundwater pumping. So there is a lot of groundwater pumping being done for different parts of agriculture, and it's not clear how huge the effect of pumping is, but it's definitely one significant factor that affects the sinking of deltas. Why am I talking about deltas so much? Now, deltas are very important areas for rice production. I've picked here 3 Asian countries with large deltas and indicated total rice production, and then the share of rice production in delta areas versus non-delta areas. And you see here in Vietnam, more than 70% of the rice from Vietnam is being produced in the Mekong and the Red River Delta. It's a little bit more difficult to estimate that from Myanmar and Bangladesh because it's not so clear where exactly the delta would start and end, but more than 50% of rice from these countries also come from delta areas. So in summary, we find increasing CO2 levels. We find therefore increasing temperature and then a rise in sea levels. And we have indicated that deltas are sinking. So altogether, how should I describe it? We're kind of in a hot mess. And the question is, what can we do? Now, this is one thing that we can do. And I'm afraid that many countries or many people do exactly that. But we can also do other things. We know that we have adaptation and mitigation measures, and we need to invest into them appropriately. And I want to give some examples for rice production. So what is very important, of course, is breeding for new and better rice varieties. I show you here a picture that you may have seen before. It's quite old. It's the discovery of a gene that is for developing of flood-tolerant varieties. So it's called sub-1. And what you see here is rice varieties in white that don't have the gene, and rice varieties in yellow that have this gene. All the rice was flooded for 3 weeks. The water level went down, and then rice with this sub-1 gene has recovered very well. The other rice plants did not. They basically died. Now, flooding, as I mentioned, is one important factor, but another factor is salinization. And it's a much more difficult story, but also in terms of salinization, some progress has been made recently. Here, a study by Mukherjee et al. They have used IR64, kind of standard varieties that many people use to compare their results to, and they have introgressed salt stress tolerant genes into this variety. And then they have exposed seedlings of this rice to salt stress for 10 days in different concentrations, 100, 200, 300 millimoles. Just to say, 200 millimoles is already very high for rice. Usual rice varieties cannot survive in this concentration. 300 millimoles is a very high salt concentration, where we're beginning to get into concentrations where shrimp is grown. And you see IR64 does not survive 10 days of this salt stress, and IR64 also does not recover from the 200 millimoles of rice stress, of salt stress. But you see all the other seedlings that have one or both of these tolerance genes in them, they recover very well, and therefore indicates that they have a much higher salt stress tolerance. Now, in the beginning, I've talked about emissions, and the question is, can we also develop varieties that have lower emissions, inherently lower emissions? And there was one study about 10 years ago from India, again, where 10 different varieties were grown, and the cumulative methane emissions in one cropping seasons were analyzed. And you see quite a difference between the varieties. IR36 here was one variety, has quite low emissions as compared to many other varieties. Now, what you need to consider, of course, is the growth duration of these varieties, and IR36 has a much lower growth duration. It's only 110 to 120, maybe 25 days, whereas the other varieties are rather long growth duration varieties. But you see, even in this a subset of long duration varieties, you see quite some differences And within the recent years, more of those studies have been conducted, more data is coming together, so that at some point we may be able to identify clearly which varieties have lower emissions. We've had one experiment earlier this year in Vietnam together with Hohenheim University, and where we analyzed 20 varieties. We wanted to show some data to you today, but due to the COVID situation, the results take a bit longer. So you may have to wait another year until the next Tropentag for these results. But not only we can reduce emissions with different varieties, there are lots of technologies available for rice production that reduce emissions. And I've talked about that many times, so I did not want to repeat that, and I want to try to do a bit more comprehensive analysis today. Overall, if you put four of these technologies together, you can reduce emissions by about 2/3, 65%. For example, if you plant short duration varieties, as we learned earlier, if the rice variety is in the field for a shorter time, also the cumulative emissions are lower. If during rice growth you switch to non-continuously flooded rice production, if you allow aeration of the soil, aerobic soil conditions, and therefore change the bacterial composition in the soil, you can reduce emissions quite strongly. Then after harvest, you have straw, and if you include the straw in the flooded field, it would have very high emissions. But if you let the straw decompose aerobically or remove the straw from the field, then you can reduce emissions quite substantially. And then again, if you do incorporate straw into the field, you can do it much earlier on in the season, which reduces the emissions as compared to if you incorporate straw shortly before planting. But I've talked about this many times, and I want to now end with a slightly different analysis of the carbon footprint of rice. So you see here again a different scheme of rice production. Here's the cultivation, crop establishment, flooding, fertilizer, and we have different technologies that can be applied during the cultivation period. But rice production doesn't end here. Rice is being harvested, it's being dried, it's being stored, it's being milled, it's packaged and transported. And all these steps have their own greenhouse gas emissions. And at all these steps, there are some loss that occurs. And so if you apply more efficient technologies, then you can reduce not only the emissions during these steps, but also reduce the losses. And we've tried to analyze that. Here you see a business as usual rice production system with about 2,500 grams, so 2.5 kilograms of CO2 per kilogram of rice. Green is the emissions from the cultivation. Then you have the emissions from the post-harvest processes. And then you have emissions that we call latent emissions because they occur due to losses. If you apply water-saving technologies, you can reduce the emissions of the cultivation process. And then if you apply best case scenarios, which means you apply better technologies for harvesting, you switch to a combine harvester, you move away from drying the rice on the street, but use a drying facility, better storage facilities, you reduce not only the emissions of the post-harvest processes, but also reduce very strongly the losses. And therefore you can cut the carbon footprint of rice in half. Now, my last slide, I want to think a little bit about how can we now make sure that these technologies are being applied. And in recent years, there was a lot of talking about carbon credits from rice. You may have read 2 or 3 years ago that Microsoft has bought carbon credits that have been earned by US rice farmers. They have basically also applied water-saving technologies, reduced the emissions, and could then, with a verifier, verify and sell those carbon credits. Also, a telephone company, AT&T, wants to experiment with that, and they want to put sensors in rice fields that analyze when the rice crop needs water, send a signal to pumps, and then have automated pumps that deliver exactly the amount of water that's needed and not more. And with the same data, you can estimate in emission reduction. Now, for us, of course, the question is that also feasible in smallholder systems? And this is in the very early development. So we have, of course, developed simple field water monitoring sensors that can give farmers a signal on their cell phone when the water level is low. We can also try to see, can we combine that with automated pumps, and can we use that as a scheme for carbon credit generation? But again, this will need much more development. With that, I conclude. I've started with a very happy note. Corona has achieved our 2020 goal for greenhouse gas mitigation. Although it was a very harsh reduction, it did not give us a big head start, but really just achieved our goals for the year. We've talked about that climate change affects rice nutrition negatively. And then we went to the deltas, have seen that they are very important for rice production, but also strongly threatened by climate change. And then for rice, we've seen there are various mitigation and adaptation strategies available. Some already matured for outscaling, others in the development phase. But what is really needed is immediate and larger investments into outscaling and development of those technologies. And with that, I say thank you very much.
Thank you, Ole. This was your applause. I hope you heard it.
I heard it. Thank you.
So thanks for this overview of climate change and rice and mitigation options. I'm fascinated that you still smile. You know, if you look at that bleak future for the deltas, you have so much work ahead that I would be worried in your case. But fortunately, there are people who are doing this kind of work. We are running a little bit late, but I think that gives the poster award people more time to actually select the proper posters. So we take some questions. And there was one question here, which I would like to give you from the audience out in the internet. And that is regarding rice protein. Irmgard Jordan says here, rice protein is not of the best quality, lacking essential amino acids. Rice-based diets support stunting, thus we need animal source foods and/or legumes plus vegetables. Taking this into consideration, we need in some regions more legumes, pulses, and animal source foods. How does this work in terms of climate change? And I think she's addressing basically the Mekong Delta in this case. So do you have a take on that?
Absolutely. I fully agree with everything that she said. We need more diversified diets. Rice has a certain amount of protein. Yes, it's not of the best quality, and we need to mix that with animal-based protein. There's nothing that I would say to the contrary of that.
Thank you very much for your presentation. I had, first of all, a thought, maybe we need more erosion for the deltas to save a little bit the area, because you get some sediments in it. But the point which worries me a little bit is, and the former comment was just joking because we don't want to have that back. The other point is looking at reduced organic material on the fields. Don't we have then any problems regarding soil organic matter in the soil, which compromises cation exchange capacity and so on? And in other areas, we have a lot of struggle with the reduction of soil organic carbon, which degrades the soil. So isn't that the right way?
Yes. So there is, of course, so different. It's a difficult answer in that case. Yes, we need to make sure that we achieve that we do not erode the soil, that we put organic matter into the soil so that we keep rice production high, or generally agricultural production high. We have a long-term experiment at IRRI where for 50 years or 60 years are close now, the complete organic matter has been removed from the field, and soil organic concentrations have not changed. But then what I think hinting at is, if we apply mitigation technologies such as alternate wetting and drying, where we remove the water layer from the field, there may be the danger that we increase soil respiration, have higher CO2 emissions, and therefore reduce soil organic carbon. And that's indeed could be a problem. But if you apply both together, if you put organic matter into the field while applying alternate wetting drying or any non-continuously flooded, you can achieve both. You can still reduce the emissions, maybe not to the same extent, but you reduce emissions, and you can make sure that your soil organic carbon levels remain high.
Thank you. Here, there is a question online which is a little bit too complex to be answered right now, so I would like to ask you to answer this later directly. And here in the lecture hall, we still have a question from Regina Birner.
Yeah, thank you for your fascinating presentation. My question is, where do you see the role of genome editing using CRISPR-Cas or other such methods in addressing the climate challenges in rice production? I mean, there is this argument that these new technologies could really help with regard to salt tolerance, flood tolerance, other issues you mentioned, even protein quality, micronutrient content of rice. So where do you see really the potential of these technologies, and how do you think that the societies will react? Because it's a contested technology. Golden rice obviously never made it. So where do you see the role in the future of these new technologies?
So first of all, golden rice has not made it yet. There have been quite some improvements in the last year or two, so that I'm still confident that we will also see golden rice in the field. Yes, you hit on a very important technology. CRISPR is often seen as a magic bullet for anything and everything, and I am not an expert in that. But of course, in terms of mitigation, as I showed, if we identify varieties that have really, to whatever reason, lower emissions, and we identify those traits, we can also then potentially use CRISPR to specifically change certain traits of the rice plant to make sure that the emissions are lower. And the same would be true, for example, for the protein content. I showed you it goes down with higher CO2 levels. If we understand why that happens and understand it on a genetic level, then we can of course use new technology to specifically potentially change certain things in order to not let that happen. So again, I'm not a biotechnologist, and I only understand CRISPR as potentially can do everything we like. So there are various options that can also be used positively for rice. How will that be accepted by people? I don't know. It's the main pushback comes from people in countries that have enough food and that have access to sufficient nutrition. So if we can finally overcome this divide, and we see that there is a need for people to use these technologies in order to get sufficient nutrition, then I think it can also be accepted.
Yes, thank you very much. And as I said, there are some more questions in the online bit. Maybe you can look at them later. Thank you very much for this talk and the discussion. It was a pleasure listening to you and having you here. And there's another big hand for you here.
Thank you very much.
And we have a final keynote for this Tropentag now coming from an economist. And this maybe you can start already arranging the lecture hall in the way while I'm introducing Michael Brüntrup from the German Development Institute, where he is a senior scientist now. Michael holds a PhD in agricultural economics from the University of Hohenheim, so another very successful output from our university. I'm very happy about that. Michael leads the research program on transformation of economics and social systems, and his work focuses on several aspects: agricultural trade policy, supply chain, rural development, food security, drought resilience, and all this mainly in sub-Saharan Africa. And so he is a perfect expert to address, again, our title, food security, nutrition security, and its resilience to global crises from now an economic point of view. And as we all know, economics makes the world go round. Huh? And that is maybe something we need to stop. I don't know if you have a take on that. Michael is going to give us his keynote in a second. We are still working on the, yeah, here we go. And I have a microphone for you here, if you want to use this. No, they don't work. It's either this or that. Okay. Einmal Hals. Genau. Da ist so ein kleiner Haken. Wonderful. Okay, und jetzt muss es noch anmachen. Wenn es grün leuchtet, ist es an, da oben. Genau, wunderbar.
Good.
Okay, Michael, floor is yours.
Yeah, economists are not the best technicians, as you see. And whether we make the world go round, I don't know. Yeah, I will. My presentation is about which crisis matters. Multi-risk management is the way to go. And I take up the the title of the, or try to take up the title of the Tropentag about food and nutrition security and its resilience to global crisis in a plural, several crises. Of course, I thought of course our crisis of the day is the Corona crisis, and there are serious repercussions for food security and nutrition. Some of the simulations by large international organizations talk about 80 to 130 million additional people in food insecurity, 6.7 million children undernourished, and up to 10,000 death children per month at the end of the year due to lack of good nutrition, nutritious food, nutrition programs, school feeding programs, and of course also simply about poverty of their parents. So it is a very dire situation in poor countries, this Corona crisis, but it is not the only crisis, and that is my point. We have other crises, and I myself, I'm working on drought issues in the last years, and I want to highlight a little bit the differences between the different crises, and what that means is we need this multi-risk management at a larger level to really deal with these different types of crises. So how can I switch? Yeah, I tried it. The down keys, yeah. So this is the outline of the presentation, a few conceptual things. DIE is a think tank, not a research organization per se, so my concepts are maybe a little bit broad, but I think good enough for this discussion. Then I take some examples. I have a little bit in-depth examples about drought, a little bit less about Corona, and as only touch upon other crises. A partial synopsis, what can be done to prevent crises to become food and nutrition disasters, and but also last slide, a little bit of trade-offs. Corona crisis, or let's say crisis risk management comes at a cost, and that needs to be taken into account. I'm starting with the typical introduction. Food security and nutrition is about access, availability, and utilization of food, and about their stability. And that together gives food security and nutrition security for households. I will come back to, I think to look at different crises, we have to look a little bit more in depth. Where are those vulnerable populations? And I have here a possibility, or let's say a concept, 5 rural world concept introduced by OECD, about 5 rural worlds, which they distinguish between commercial enterprises, these quite prosperous agricultural commercial farms, then the traditional semi-commercial agricultural households, the majority of rural households which are geared towards subsistence agriculture, but who are also producing for the market. Then R4, the landless rural non-poor households, and the very critical group of chronically poor individuals without land. So not the farmers, but agricultural day laborers and so on. And to better even look at the urban sides, I have also introduced a kind of similar distinction of 5 groups: the wealthy households, then the middle class with agricultural activity. We find, especially in Africa, a lot of urban households who are still very active in agriculture. In several countries, you don't see, if you have the breakup of incomes, you don't see really a big difference between rural and urban households, because many of these urban households have either home gardening or small gardens, or they have access in their home villages to agricultural activities. Then we have this middle class, of course, also without agricultural activities. We have the poor individuals with agricultural links and the poor individuals without agricultural links. And for food security and nutrition issues, we have our most worrisome groups are the chronically poor without land, and the households geared with subsistence, which are the very poor. And in the urban areas, we have the poor in both categories. For a really big disaster, we have to also consider that also the other parts of the populations get into trouble. For example, now in the corona, if you have a lockdown of several months, then also for middle class people, it becomes really difficult to get enough income. The savings are exploited, and we know it even from the US, for example, that middle class households line up for food handouts. So if we talk about different scales of risk or shocks, we have here the risks, the more idiosyncratic risks from individuals, households to the local, and then more the collective risks for national, regional, and even global. And I think what we talk here about is not only purely global disasters, shocks like Corona, but also national and regional ones, like, for example, civil wars or droughts. Resilience, the final concept that I want to introduce, is a fuzzy concept. And there was a very nice Nature sustainability article about the different uses of sustainability in different scientific communities. I want to think this is a handleable way to illustrate what resilience could mean. It's a system which is exposed to a shock, can either collapse and do not recover, and then it is not resilient. It goes down to another system, a lower system level. It is resilient in a conventional way, in an ecological way, if it recovers to a steady state, the previous steady state. And it has even adaptive resilience, it is called, if after the crisis recovery is to a higher level of shock absorption, so the vulnerability is lower. That is what we call now, what you read in the newspapers very often as building back better. Now, coming to the first example, drought cycle management. The concept of ecological resilience is very, let's say, simplistic in a way that it doesn't really assume or intelligent way of dealing with risks, anticipation, and so on. It is a relatively, or also material sciences. It is a relatively unadaptive system thinking. In human populations, we have the possibility to anticipate what happens. We can build up more resilience activities, and we can build back better. And this is shown in the typical example of a drought cycle management, where we have these proactive activities before the disaster. In this case, the drought really strikes. We have early monitoring and early warning, so we can know in advance what comes up, at least to a certain degree. We have vulnerability assessment, so we can also assess, even without the disaster, where are the problematic areas, where are the problematic populations, what are their assets, what do they need for certain situations. Then we have the large, and I will come back to that last array of risk mitigation measures that all in the before any disaster strikes. And then we have, during the reactive phase, we have emergency relief, we have impact assessments, and then the recovery and restoration, and that is where we build back better. And in the system, that is a multi-level stacked interdependent system. So we have households who can care for their resilience and reduce their vulnerability. But of course, we have also the local level, the communities. We have national food systems, relief systems. So the resilience is a layered one. And although it is preferable to have resilience at the lowest level, I call that a subsidiarity resilience. So it's better if households themselves are able to cope with the shock. But we have to acknowledge large shocks during large shocks, households will not be able. A large drought in sub-Saharan Africa means 3 years of consecutive lack of precipitation, and even no irrigation system is then able to recover and to absorb that shock. So the elements of drought risk management are, for example, here I have there are policy domains like land, water and landscape management in the agriculture sector, but also in finance, in social protection, food markets, general economic development, and energy. And just to name a very few ones, you see that there are many more examples. For the landscape and water, we have already heard in one of the previous keynote speeches about watershed and integrated water research, water management, water resources management. During a larger drought, we have maybe to go to water rationing because agriculture is absorbing too much water. We have seen that in South Africa, for example. In a large drought, we need to reduce, to abstain from using water for irrigation and use it for people and for livestock. In agriculture, we have, for example, breeding for drought resilience. We can establish seed and fodder storages. During the drought period, then we need to redistribute the seeds. So very often farmers have no longer their locally adapted seeds, and so the stores have to be storage has to be used to redistribute the adapted seeds. And also, for example, there are periods in the lowlands where you and in livestock in pastoralist areas, that's the word that I'm looking for, we have to go for slaughtering animals. So in order to save the few animals for later breeding, we have to slaughter a lot of others in order to save resources for later. In the finance, we have savings, credit, and insurance, and during the drought periods, we have to withdraw it. We have to adjust the credit conditions, and we expect that there is payouts of insurances. Social protection during the non-drought period, we have to establish it, and we can use social protection schemes, for example, food for work programs, to build resilience either at the local, at the household level, or at the regional level. And during the drought period, then we can scale up. If there is already something like a social protection scheme, we can scale them up and further use them to build back better. In food markets, we need open trade, because if during a drought period we need these food imports, as I said, this local agriculture systems will collapse at a certain moment, and then we need food imports. But these will not happen if we have not established food trading in the regions previously. Then we have to completely rely on emergency systems. You cannot scale them up from zero. You have to have something, and that is a difficult, of course, condition because open trade means that you cannot protect your farmers as you maybe want during a normal time. The general economic development means that you go for diversification of income so that during the drought period you can rely on non-nature based incomes, and on the energy side, similarly, diversification so that you have energy, non-hydro energy during your drought periods. So that was the drought story, the resilience. Now, if I compare drought with COVID, I find quite some differences in in several aspects. For example, the likelihood of drought is frequent in many places, whereas the COVID is really a rare occasion. It is the black swan. In the long run, whether we will have more of this pandemics, I don't know. Is it a primary or a secondary order impact? Drought is directly impacting on the food availability, whereas COVID is, these are secondary effects. They are imposed, or they are derived through the measures of governments, the lockdown measures to stop or to prevent the rapid expansion. So there is much more policy leverage for food security in a COVID situation than in a drought situation. Most affected in drought are the rural populations, and all of them, all these types, whereas in COVID it is the urban poor in the short run, and in the longer run maybe even urban middle classes. Agriculture shows to be the most vulnerable sector during a drought period, whereas during a COVID, it is the fallback. In many countries, we have now the rural areas being less affected by these lockdown measures. Non-agricultural local incomes are the fallback position during the drought, but these are the most vulnerable jobs during the COVID situation. Remittances during a drought, again, they are important sources of income. In COVID, we know that remittances have dropped tremendously because these low wage earners abroad are those who have been released from the labor markets the first. The local regional food supply is in drought regions often insufficient to feed the population, whereas in COVID situation, it is the backbone. But it is affected by lockdown measures, so in the trade regimes. The markets during a drought period are not affected. It is a non-destructive disaster, whereas in COVID it is affected, although it's also not destructive, but it's the lockdown measures by governments. And the food prices during a drought increase, at least locally. That is, I think, the case for almost all products, maybe except for meat in pastoralist areas, whereas in COVID we have a general reduction of prices because the demand, the purchasing powers are lower. So multi-risk approach really makes a difference about what is the right measure for food security. Now I'm going very briefly through some of the other global shocks. These are examples from World Economic Forum Global Risk report. So we have economic and environmental risk, and for food security, I would say the macro shocks with unemployment and where state services are failing, these are the most critical for food security. And in the environmental area, it is climate-related shocks and biological disasters. In the geopolitical, societal, and technological areas, it is conflicts, it is pandemics, and it is water crisis. And in the technology, maybe it is cyber, because if cyber crisis affects international trade, I don't see it directly for being very relevant for developing countries, but for international trade is more and more relying on information exchange and on ICT technology, so they are more vulnerable. So what does it mean? A multi-risk approach is really necessary. We have several risks which are really a threat for global food security and nutrition. And now I'm coming to a first partial synopsis. What can be done to increase resilience? Again, for all these crises, we have instruments of early warning and vulnerability assessments, and these must be continuous. Then we have a set of approaches, and some have been mentioned in previous presentations: agricultural resilience through better water use, soil carbon management. There are many individual technologies. We can go at the ecosystem and water resilience, so the watershed level, and even beyond the watershed level. We need plans, for example, to stop withdrawing water for agriculture in urgent emergencies. We need this diversification, not only of incomes, but also of food supplies, storage and trade for that. Then we have a couple of, I think, universal instruments, which are insurance, savings and credit. Then the solidarity networks and social protection schemes, and wealth itself is a protector against crisis. During crisis, we need this building back better approaches and the flexibility of instruments. So that is, for example, in the developing community, it's very important to have projects which can switch from a normal situation to an emergency modus easily, without having to go through a project cycle planification again. So that is contingency planning for emergency situations. And then we need adaptive policies, which means policies which really are evaluating itself, which are looking continuously how they behave under emergency situations, and we need this behavioral change. But and I think that is a nice list, but, and that is now my last slide, resilience comes as a cost. Very many of these means are very costly. And I have again gone through this trade-offs, and you will see, for example, in the water area. Water storage is a good thing, but it of course sometimes prevents people from using that. No? You can only use water 1.5 times, but not several times. And that is a difficult decision to make, how much water to store or how much water to use immediately. In the breeding area, it has this, I think it is a little bit similar. You have breeding for competing types of resiliences, and your trade-off is with maximum yield under normal conditions. You have in finance, you have to pay premium for insurances, which is going, usually you do not, you have a reduction of your income and of your investments, and it makes you more risk averse in a sense. You are not acting in a risk neutral manner where you have a higher typical expected return. In social protection, you seek for high resilience, a broad coverage of the population, but that is very costly. And also we have a lot of reports where it reduces self-help motivation, because people start to rely on social protection. The food markets I've already mentioned, you have this, if you want to have a balanced food markets, you may want, for example, to invest in new areas. You don't want to protect your farmers too much, but that comes at the cost of efficiency, because as economists we know that strong interventions of governments into food markets come always at an efficiency, a welfare cost. So you forgo short-term gains. For general economic development, I think that's the same story. You have diversification comes at a cost for efficiency and for medium-term growth. And same for energy. You have the costs of a strongly diversified energy system can be very substantial. In addition, if all these things which intervene, where the private sector, but also particularly the public sector, tries to balance short and long-term benefits and costs between resilience and, let's say, business as usual, you get into the political economy of things. You have, because segments of the population and of the private sector will try to shape the policies in one and other direction, and very often it is power play, and the richer, the elites, and especially the existing elites in this existing sectors will win in this power play. And that brings me to, unfortunately, to my last point, is that the multi-risk approach is the way to go, but it is quite difficult, and it needs a lot of negotiation and of careful planning also. And here comes maybe also economists, but also political scientists into play to carefully balance the costs and benefits of this of multi-sectoral, multi-risk approaches. Yeah, thank you.
Yes, thank you, Michael, for this analysis about crises. I think that was really quite, for me, still something hard to digest. And there's directly a question from Andrea Fadani. Can we prioritize crises, and should we actually do that? Prioritize.
Prioritize. We must come to a prioritization. That is one of the lessons, I think, from this. I mean, you cannot prevent or you cannot prepare for all these crises in the same way. So yes, there must be prioritization. And for example, in the Horn of Africa, drought definitely is a major crisis, which you know that it comes all 2 to 3 to 4 years. The predictions from climate change simulations tell us that maybe these droughts will reduce in that area. But for the time being, we have it, and so clearly that is sometimes, for example, if you establish savings insurance schemes, I think you can have this double win-win situation. So for certain crises, you will have insurance being useful for a drought, for a flood, for another crisis. If it is in a country with a heavy inflation, you have to be very careful, because the inflation eats up insurance and specifically saving schemes very quickly. And many of the African farmers are nowadays very much, for example, skeptical against savings cooperatives, because they have experienced that their cooperatives, and sometimes it was even forced savings, they have lost a part of their fortune for this. So again, here there is a need for selective and for prioritization. It is difficult to make. It should be kind of consensus where to prioritize and not completely neglect some of the issues which may arise from other crises, which are not immediately, which may also only derive every 20 to 30 years.
Okay. I heard some noise in the background. Is there our Tropentag god speaking to us? No? Yeah. They are speaking, but not to us. Okay. There's a question here from the audience in the lecture hall. Regina Birner.
Yeah, thank you for this very insightful presentation. My question is is there not a need for more, I would say, adaptive learning from these crises over time? So for example, you explained the COVID crisis, which has quite different effects, and what many governments experienced if they put in the same lockdown measures they have observed in other countries, yet they have large shares of food insecure population. There are models that predict that the losses from food insecurity or from not having vaccinations and all these kinds of health related issues may be even larger than the losses avoided through these measures. So maybe in the future one would have to take that into account. But what is your experience with this building back better? To what extent are governments, with all the political economy challenges you mentioned, actually able to learn over time on how to manage these risks in a more, also site-specific way?
Yeah, that is what I called here this adaptive policy making. No? It would be absolutely necessary. The experiences is that, and I see that, for example, in the COVID crisis, that is why I'm a little bit warning. The development cooperation, I have the impression, is now completely shifting towards anti-COVID measures and neglecting some of them. I mean that we seem, and that is also psychological, we all seem to always react to that crisis which is in front of us. Then there is a kind of normalization process, and after, I mean, in Germany we know it, that we had all these reserves for masks and for food and so on for a long time, and then we have forgotten a little bit about the crisis. How to do that? How to have a balance? This prioritization, yes, but not shifting from one extreme to the other. I'm not sure. I think that science maybe has an important role to play, because they can a little bit, they are a little bit off, let's say, the local policy dialogues, the daily dialogues. They can bring in this warning. I mean, that is sometimes is a very unsatisfactory role also for science, because they are also always the ones who are slip out the finger and say, and drought is also, but maybe that is one of the ways, no? And this global risk assessment, for example, they're always bringing back also the other risks to our attention, even if they are not physically present at the time. No? Maybe that is one of, but it is clearly, it is a problem, this adaptive policy. There is a overreaction of political systems. It seems of all systems, not only of democratic systems where you could understand, but look at China or other non-democratic regimes. They are behaving in a similar way, overreaction. We have to also maybe show them the cost, the cost of that. And this, for example, in the COVID crisis in Africa, the tremendous cost of lockdowns in terms of food insecurity, I think that they have not been really taken into account. And I know about Indian scholars who have said their governments seem to have completely forgotten about their 100 million migrant people whom they have sent on the road within 4 hours. And that is also, for me, that is something where they have forgotten one crisis or one vulnerability when reacting to another one.
Thank you for this extensive answer.
Sorry.
Which now brings us to the end of this session. There are more questions, and I have seen them, but we will not have the time to answer them here. So I asked Michael, as I asked the others, to go into the questions and answers and maybe find some answers for the other questions here as well. I also saw that there was a question from Petra, probably. Maybe Petra could actually also write it into the questions and answers, and then we have the discussion later. Because we need to continue here. They didn't really say anything yet, but we are 15 minutes late. And as far as I know, the next thing on the agenda is the award of the poster prizes. And I have to ask people in Witzenhausen, are you ready for this?
Yes, we are.
Ah. Eine Hülsebusch-Stimme aus dem Hintergrund. Very nice.
Actually.
Okay, then we shop. Ah, there. Yes, Eva and Hülse. Welcome. Welcome and hello to Witzenhausen.
Can you put on this one number 0?
As far as I see, you are sitting in your digital office.
There's only one picture.
We are sitting in the digital office, and I have Eva with me because she was one of the poster judges.
Wonderful. So I hand over to you, and whatever you want to do now is yours.
Okay. Thank you very much. Dear Tropentag community, also on a virtual conference with all the technological difficulties, particularly in presenting posters, which is normally a much more social and close event, we still have decided to give out a poster award. And we have the community also on the virtual conference with all the technological difficulties, particularly in presenting posters, which is normally a much more social and close event, we still have decided to give out a poster award. Maybe just for the technology, I can hear myself talking with a time lag of about
Exactly
15 seconds. Anyway, we had every session chair of a poster session to submit their suggestions to us on what a award-worthy poster in their session was. And then we had a jury consisting of 3 people. That was Volker Asch in Hohenheim, that was Eva Schlecht and myself here in Witzenhausen, to go through the posters, and according to the criteria that we have already in place since the last Tropentags, have selected 5 award-winning posters. And I shall share my screen with you so that we can display them. Please allow me to share my screen. This is the one that I would like to share. Can you see that?
Yes, we can see that. And now also in presentation mode.
You can see that also in presentation mode.
Yeah, looks very nice. You're quite busy up there, huh?
We are quite busy out there because most of you never have seen how actually all the contributions got streamed onto the YouTube live channel. Here is a picture of Eric Tukis, who you can see here in the middle of all the IT crew. Those were the guys who brought all the content to you onto your diverse mobile and desktop gadgets. But now we get to the posters. We have one very special poster award, the number 5 in our series, and this one we selected not so much for the layout, but for the dedication of the author, who recorded a very smart presentation on her poster of response of Solanum lycopersicum tomato to tuta absoluta and glomus clarum using SSR marker. And she recorded her contribution. In the beginning, what she uploaded was a contribution that had a lot of traffic noise. It sounded like the middle of Lagos. And then after feedback with Eric, she re-recorded it, and it showed really a high degree of dedication. And we therefore felt that this is worth one of our 5 poster awards. Number 2 is George Asara from the GM Farm and Consultancy in Ghana on income and employment opportunities through cashew apples processing in Ghana. And that is a poster that comes from the University of Applied Sciences Weinstefan Triesdorf and GIZ in cooperation. Number 3 is Anna Manurova of Czech University of Life Sciences, and she did a very smart poster on the Zambian neglected species, oils and cakes composition of traditional oil-bearing trees. Then we have poster number 4, Iris Ramaj from the University of Hohenheim, the Agriculture Engineering Department, and he did a poster on the influence of self-compaction on the airflow resistance of grain bulbs. And finally, the poster that in our internal ranking had the highest number of points was from Ege University in Turkey, Özgür Tata, the effect of on water use efficiency of wheat. These are the posters that we have selected for this year's poster prize. We are giving out 5 prizes at euro 200 each, and we will contact the authors, given the fact that we cannot hand over the envelopes today. We will contact the authors and see how we get the awards to them. So that is, for the moment, all from our side. Thank you.
I hope you hear the cheering applause from our
Yes.
lecture hall. Very well done. Thanks to the jury. I must admit I was only part of the first 50% of these, because otherwise I had to stand here and talk. So, but very well done. Again, quite a variety of topics. And of course, we saw many, many more posters. And I must say that there were some amazing videos. Yeah, really. So much effort and so much dedication, but we were not actually going for the videos, we were going for the posters. Yeah, and so there was only one exception because of the high dedication, but normally it was the poster that was evaluated and not the video. Maybe if we continue doing these kind of things, we can also split it into looking into videos and the poster, because sometimes the video was a lot better than the poster. But well, this year it is the first time, and I thank the jury for their efforts. Now we have another top on the agenda, and that is the photo competition that was announced, and I mean already well ahead of the Tropentag. Many photos have been sent here. I have seen many also during the sessions of different quality, of different topics, and so I really don't know how the entire process worked. So I hand over to Michael, who initiated originally this competition and is now in charge of giving us the results.
Yeah, we want. The idea to this photo competition came when I have created during a sabbatical little NGO, Let's Plant. This NGO is convinced and dedicated to landscape approaches. So we are convinced that a landscape approach which integrates different elements like forests, trees, watershed management and so on, that is the way to go. In rural development, let's say, in developing countries. And we thought that in this case, pictures can tell a lot of stories, sometimes much more than long papers. And so we elicited, we asked the Tropentag to allow this large audience to also send in pictures, both individual pictures of landscapes and photo stories. All of these pictures should, of course, be supported by a story which tells about this, about the pictures, what they want to convey. These are the, we had, I think, 28, if not 32. There, most of the submissions came in the last day, the last few days. So we had a little bit problem of keeping up with the submissions. You'll see that we have submissions from, I think, all over the world, the developing world. And I hope now what we wanted to do is to have a short, extremely short introduction to the prize takers by our jury composed of 4 persons. I don't know whether they are now here in this Zoom meeting. That was the idea. Aha. If that is the case, then I would like to start. I think Marion is the first.
Yes, hello. So Exactly. For the single picture in third position, we have the contribution from Sushma Banjara, who is a master student at the University of Agriculture and Forestry in Chitwan, Nepal. And she sent us a very nice picture on post-disaster agricultural transition in Nepal. So she explained to us that following the earthquakes, there was a lot of construction in the lowland of Nepal, and that it pushed to the cultivation of off-season vegetables in the lowland also, because the land is so scarce. So they shift a little bit the type of production. And in the upland areas, there was more afforestation actually. So, and she got the third prize as a single picture. I'm not sure she is in the Zoom, so.
Is she also there? Exactly. That.
Oh, okay, sorry.
That is a question. Is she also in the Zoom meeting? We don't know. I don't see her. Yeah.
Okay. Then we can switch to our winner in third position for the story.
I can even not switch the position. The arrow has been lost.
Okay.
Yep.
So this is a contribution from Elio Guaronex from Mexico. He's working for the NGO Pro Natura Veracruz, and he sent us his photo series on mangrove restoration in the Ramsar site Alvarado Lagoon system from Mexico. So Elio, I see you are online, so maybe you can tell us a little bit more about your picture and your work.
Hello. Yes, thanks for the presentation. Well, we're focused on restoring several degraded parts of the landscape in this lagoon system in Mexico. And we have learned a lot. This process, mangrove restoration, you have to it's not only about planting, but you also have to, as you may see here, you have to protect mangroves, which are wetlands and are mostly wet throughout the year. You have to protect them against fire. You also have to supply them water, to improve the water flow, and this is like the success we've been having. As you may see here, these are mangrove trees already growing. This is our restoration. You may see a pattern here, and we give local people work and restoration and channel dredging. It's a very rewarding activity for us who participated there. What else can I say? And yes, we have learned, as I stated before, we have learned because we've lost and we've seen others lost restorations because of not interpreting the disturbance of the landscape.
Yeah, I'm sorry, I have only selected 3 pictures because I thought we are much very short in time. So in the full photo series, you will also see people working on the ground, so people in the landscape, how they are improving their own landscapes with the help of projects or also without. Thank you, Elio, for this nice contribution. We come to the second places. First for the single picture and then for the series. And that will be presented by Geshe from the European Forest Institute, one of our jury members.
Hello. Hello, everyone. This picture, single story, was provided by Julia May. And I was actually expecting him to participate in the Zoom to introduce himself. I can tell a bit about he's unfortunately not around, but I can tell a bit about the picture. It is showing tea plantations close to Munna in southern India, and yes, you can see that there's an amazing atmosphere that is being created by the entire tea growing region. I was expecting him to share a little bit more about this story, but unfortunately he's not around. So Michael, if you know more about the background, then you can of course step in here. And in case you don't, I would like to introduce the second prize winner for the story, which is Teresa Rojas, and she is in the call. Teresa.
Good morning, everybody.
Please tell us a little bit about the story and the entire. Maybe just briefly. Teresa's story is showing images of a forest peatland restoration in central Kalimantan in Indonesia, and this peatland restoration is linking to an orangutan conservation. And yeah, I would like, maybe you can share one or two experiences from this project and what you find most impressive.
Okay, thank you very much. First, we are deeply honored to receive this prize. And well, we are working with in Borneo orangutan survival and on the conservation of the Bornean orangutans and its habitats through the involvement of local communities. So this picture shows the work that we are doing in Mabas. This is a picture of Mabas, which is located in the ex-mega rice project in central Kalimantan in Indonesia. In the 90s, the government of Indonesia tried to turn around 1 million hectares of peatland forest into rice paddies. So for this purpose, a large investment was made in the construction of canals and removing trees. So the project failed after making a considerable damage to the environment. So Mabas is the area where we are working, has more than 300,000 hectares and is the home of one of the largest populations of wild orangutans. So here we are working on restoration of degraded peatlands. So the restoration starts, as we can see in this picture, with restoring the water table. So we want that the water increase to rebuild the surface and then to initiate the reforestation, which is also helps us to control the fire outbreaks that occur normally in this area. This is achieved by building dams, which is you can see in this picture, and then this is overplanted with vegetation. So currently, more than 120 canals have been blocked. We build around 4 dams per canal, and irrigating around 10,000 hectares. And more than 200 hectares of degraded land have been reforested using native species. So all these efforts contribute to the restoration of the peatland forests as well as the conservation of biodiversity, including species that are critically endangered, such as the orangutans. So thank you very much.
Thank you very much for this introduction, Teresa.
And again, more pictures on in the exhibition also about the technologies that they have used. I found it also interesting that they are rehabilitating land which has been used, I think also supported by science. This 1 million hectare failed rice investment in Kalimantan. I'm sure that also several hundreds of agricultural economists and technologists have assisted to this disaster in this case. And maybe also adaptive learning by our own community could also maybe be a very interesting topic for some. Now we are coming to the first prize, first in the, again, in the single category, then in the series, and that will be presented by Marco Höttke, who is the president of our NGO.
Yes, hello. My name is Marco Höttke, and I am going to present the first prize winners. I hope you can hear me well.
Yeah.
Okay, the winner in the category of single photo is Rex Parrow. He is a master student, at the University of Bonn. He's from the Philippines, and he has sent us a photo of an old nickel mining site with a secondary forest having established. And I had also hoped that he would participate, but I think he's not in the call. Is that true? Are you there, Rex?
I cannot control.
I guess not. I guess not. So I'm going to try to show what he has sent us. Oh, already the next photos are coming in. So let me just resume what he has found. He has found on a mafic, ultramafic soil, which is high in magnesium and iron, that astonishingly diverse secondary forest has developed, and so he is advocating to protect this kind of secondary forest on old mining sites. That's more or less what I understood from his story. Like I said, it's a pity he is not here. And then let's go to the winner of the photo story, first prize winner of the photo story, Jakob Scheler. And he has sent in some very beautiful photos and a very interesting story from the highlands of Ethiopia. And since you are in the call, Jakob, I would like to explain us what the story behind these pictures is, please.
Hello, everybody. I hope you can hear me.
Yes.
I hear everything twice, unfortunately. Well, the first picture shows some villagers on the way to a funeral, and also in the background, we worked in a eucalyptus production with the research group that I was part of, and in the background you can see a eucalyptus plantation. As well, you see the problem with erosion in the landscape. I still hear myself twice all the time.
No problem. We don't hear you twice. We just hear you a little low, but we are understanding you.
All right. And well, for me, the most interesting was during my research. Also, I was working on social capital and social networks in eucalyptus production. Was actually the people and how they cooperated. On the second picture, you see wood traders that harvested the trees from the farmers and loading it onto a truck. And yeah, as I said, we worked a lot with the farmers, and we did a lot of interviews and focus group discussions. Here you see our leader of the research group, Dr. Asmama, and some students from Ethiopia engaged in talk with the farmers and the landscape. You see the landscape is heavily in use, and eucalyptus provides a good opportunity for people to get access to firewood and also, yeah, cash income. The natural forests were heavily under pressure in the highlands, and eucalyptus sort of is the way right now for the people there.
Yeah, and the photo story tells the whole value chain of eucalyptus in some very nice in a pictorial way. And it also highlights some of the ecologically problematic areas of eucalyptus, without denying that, as Sheila says, it is the way to go, because that provides really so many advantages on firewood or construction wood, on using them as fences and so on, that the whole landscape, a completely degraded landscape in northern Ethiopia, has been recovered into large extents through reforestation. It began with eucalyptus, and now increasingly also local species are introduced. I think that northern Ethiopia is a very nice story to tell when it comes to landscape restoration. Thank you very much for all of you. We have ended our photo session awards ceremony. It was the first trial. Next time, I think I will bring in the whole photo stories. I see that I have enough time to manipulate here. Yeah, thank you.
Yes. Thanks to the jury for joining us. Thank you for Michael for introducing this idea that has potential to be developed, I think. And it's a good new feature. And let's see what comes out of it. Normally, we would have seen the video of the student reporters at this point in time, but there is no video of student reporters. There's actually no student reporter, but there is Ralf Dickerhoff, who has reported for us in the blog. And I only can ask you to see his work on the blog. We will not hear anything from him now. But what we will hear now is, before we close the session finally, we will hear from our colleagues in Hohenheim. I hope that Misek is there. What we have planned for next year. How are we with Misek? Hello, my friends in Witzenhausen. They have left us. Hello, anybody out there?
Witzenhausen is still here, but we can't see Misek.
Yeah, but do you have his presentation? Is he there?
No, I don't know. Maybe the IT host number 7, Ataf, do you have a presentation of Misek?
Doesn't look like it, eh?
No reply currently. No. We just go and check.
Yeah. Actually, Misek was asking for the link to the video conference here. I hope somebody sent it to him, because I didn't have it.
I abused this little technical disturbance to say something which I have forgotten. The photos will be further promoted by us. We have several occasions where we will show these photos online in the Stadtforest of Bonn on very large posters, and also use them for advertising the idea. So it's not only about this photo competition and the prize here. It is really, we want to use these photos and to spread the idea of landscape restoration. That was something which I urgently wanted to say. Thank you.
Thank you.
Okay, I see that Misek has just joined the meeting.
Ah, okay. That's good. So then he needs to, yeah, we have one more participant. Misek, are you there? We need you to speak to us.
Misek is not there anymore, but I see Eric connecting to audio, and Misek also now connecting to audio.
Ah.
Actually wanted to say. Thank you.
Thank you.
Okay, I see that Misek has just joined the meeting.
Ah, okay. That's good.
Yes,
So then he needs to, yeah, we have one more participant.
Yep.
Misek, are you there?
I'm now there. I'm sorry, the technology was not working very well for me.
Is not there anymore. But
Yes, hi, Misek. We hear you, but we also hear the video channel in the background. But we can't see you.
No,
I see that Misek has just joined the meeting.
That's right.
Okay.
I've managed to join the meeting.
Yes,
So then he needs to, yeah, we have one more participant.
Yes.
Ah, there you are.
I'm there now.
The technology was not working very well for me.
So,
Not there anymore, but
Yes, we hear you. This is really funny because we are hearing the time delay from the YouTube channel. Are you listening to the YouTube channel, Misek?
I work. Right. Okay. I've managed to join the meeting. Yes,
Yeah. Anyway, let's not
sorry.
disturb him.
I'm
Now we hear
actually
you quite
there.
well. Would you mind sharing your screen and giving us the welcome to Hohenheim next year?
I will do that. The facility that what I need to do is to be in the Zoom, which is it's not allowing me to.
Can you please let Misek share his screen? Regie?
Yeah, so if the organizers can let me share the screen, then I'll be able to do that.
Is there anything we have to do here? Okay, try to share your screen.
Right, okay. I think now I'll be able to share my screen.
Ah, something's happening. Yes. Now, presentation mode. Ah, you start with slide number 5. Amazing. Here we go. Floor is yours.
Right. Thank you very much. I'm really sorry for all those technological problems. So my name is Misek Chagunda. I'm at the University of Hohenheim, where I chair the Department of Animal Breeding and Husbandry in the tropics and subtropics. And I'm speaking on behalf of the organizing committee for next year's Tropentag. Now, before I proceed introducing next year's Tropentag, let me just take a very quick opportunity to congratulate the organizers for making it possible for us to have Tropentag this year. We really appreciate in this year where Corona and COVID-19 threw everything on us, you still managed to give us a very excellent conference, complete with a concert last night. That is really something very commendable. I think I'm not speaking on behalf of myself. I'm speaking on behalf of everybody who attended the conference. We really appreciate your efforts. Now, the thing though is I need to introduce the conference for next year. But then the thing is, we cannot look at the future without having a very quick shoulder check of the past. And one of the threads that has been coming in through and through during this conference is the issue of crisis and resilience. This has even been ably underscored by all the keynote speakers this morning. And it's with that the organizing committee for next year had thought about what then can we do for next year, which builds on this year and also looks forward into the future. As such then, the theme of next year is towards shifting paradigms in agriculture for the health and sustainable future. This is what we would like to have a discussion on, not only to start that discussion, but also to continue the discussion that has already started. The thinking behind it is that we all need to perceive agriculture as something that's in line with nature, which of course we are all part of. We need to shift the paradigm to a positive relationship between humans, environment, ecology, and nature. Only products produced in line with the need and requirements of the planet have this positive outlook. And this is what our mindsets should be on. If we can achieve this, we may be able to still save the planet, or at least contribute to that effort of saving the planet, and also providing a healthy environment and healthy population and a sustainable future. And that is the reason we've come up with this theme for next year's conference. Where will this conference be held? In the southern part of Germany, at the University of Hohenheim. We have a very long tradition in the Tropentag and also in tropical agricultural production, which we would like to share and network on with colleagues who have common interest in this issue of tropical agricultural production. We are based, like I said, in Stuttgart, or just in the outskirts of Stuttgart, but we are actually very close to reach, very close to the airport for those who will be flying in. Very close, we have very good train connections for those who will be coming by train. And we also are very close to the main road networks. People have said this, and I think they are not really wrong. They say we are the one of the most beautiful campuses in Germany. And I think they are right, because we didn't just say it ourselves, we heard it, people say it. So I think they are right. Apart from being in the tradition of Tropentag for some time, we've also, as a university, have had a long tradition in agriculture, in tropical agriculture, and also in dealing with problems that people see as practical problems that affect real production systems. 2 years ago, we were celebrating 200 years, and that gives us 200 years of experience in this area. About 15% of our students come from international students. So we also have quite a lot of experience dealing with global issues. Currently, our university has about 10,000 students. We have 3 faculties: Faculty of Agricultural Sciences, Faculty of Natural Sciences, and Faculty of Business and Economics and Social Sciences. Talking about our experience in agricultural production systems in the tropics and subtropics, we have a collection of scientists, researchers, academicians who work in this area under the banner of Hohenheim Tropics. But more specifically, we also have the Institute of Agricultural Sciences in the Tropics, which has 10 specific chairs working on areas such as plant production and agroecology, agriculture economics and social sciences, animal production, and agriculture engineering. And we are fondly called the Hans Ruthenberg Institute. With that, I would like to come back to the theme for next year, towards shifting paradigms in agriculture for a healthy and sustainable future. We look forward to welcoming you in Hohenheim. We look forward to having a successful conference. Thank you very much. And as we are finishing this conference, we wish you all the best and stay healthy. Thank you.
Thank you very much, Misek, for this introduction to Hohenheim and the invitation to the Tropentag next year. We are very much hopeful that we can do it as a full-fledged Tropentag again, but now we had a test run with a virtual Tropentag and we learned a few lessons from that. And we are going to see what kind of lessons that were when we do the evaluation of this year's Tropentag, because so far we only have split images of what really happened. But one thing is very clear, there was a huge team in the background that was actually handling the computers, and they were there all the time. They were listening to all these things in Witzenhausen. We did it here in a real life session in Hohenheim, thanks to Mark Giese, who really put a lot of effort in making it happen. He was negotiating with our hygiene team here, and so everything worked quite well. And so in the end, a multi-locational Tropentag with online activities, even an online concert, was finally realized. And out of all this, we have seen a few things that are good and we may keep. There are a few things that we just don't want to have anymore and want to get rid of, yeah, like our coffee breaks behind Spuckschutz. That's something weird. So that is something that we would like to change again. But in every bad, there may be something good. In every challenge, there's an opportunity. And I think we did well in answering to that challenge. And I would like, normally we would have all these people who were involved in organizing the Tropentag, we would have them here now in front and everybody would clap. But since there are only few people here to clap and no people that we could actually bring up, I will thank everyone on behalf of everyone else for the efforts that were put in. And I'm sure that we will have some residual effects because the Tropentag will still be online. That's also new. There is a possibility to revisit sessions. There is a possibility to still ask questions. And there's still a long-term possibility to interact for at least 4 weeks or so online and keep the network alive. With this, I would like to close the session here in Hohenheim. And I hand over to Witzenhausen for closing remarks and closing the session from there. What did I say, Hohenheim? No, Witzenhausen, of course. Are you still there?
I'm still here. That comes a little bit as a surprise.
Misek, you should stop sharing your screen. That would be very helpful. These handover things, they do not really work yet very well. Huh? Hello. Yes.
Hello.
Christian.
Yes, I'm here. Comes a bit as a surprise that we should actually close.
Yeah, I thought that Eric is going to close because he's the one on the switch. Huh?
Eric is up in the engine room, but I can't see him in the Zoom session. So maybe Eric could join us briefly via the ATSAF TT 2027 IT host. Do you read me?
Well, apparently Eric is busy.
Apparently Eric is busy. So then it remains for me to bid farewell to all those who are still listening. And I must say the person who did the main job in this Tropentag is Eric. Now Eric has joined us. Eric. There he is. Now I shall mute and hand over to Eric.
Yeah. Hello. Yes, there I am. Do you hear me?
Oh yes.
Okay. Yeah, I want to thank especially the crew here in Witzenhausen. I think they did a great job. It was a new experience for us. So give a hand to all them. There are a few data that I still can give you. We were actually 738 persons from 67 countries. And we had over 2,700 hours of total view time and almost 6,400 clicks. So that means a mean viewing time of 26 minutes, what I think was a great and very interesting. So with these last words, I want to close it. And I think that was Tropentag 2020, and we are looking forward to 2021. Bye-bye.
Bye-bye, Erik. Thank you very much.